Hi, I'm Brad Mickley. I'm one of the project leads of KitOps, which is the only open standard for secure AI/ML project sharing and storage. You can learn more about KitOps at our GitHub repo right here or at kitops.ml. Now today, I'm going to show you how you would integrate ModelKits in with a Jupyter Notebook. This gives you a really good way not just to share the various project assets in an easy and kind of modular way, but a much more secure way to store those assets. Super important if you're, for example, in the EU and prey to the EU AI Act, or if you're in a regulated industry, or just honestly, if you want to make sure that your data and your model as you're developing remains tamper-proof and secure at all stages. I'm also going to show you how to use KitOps and that kind of get that same secure project benefit with experimentation tools like MLflow. That'll be for a separate video. Now there is another video that kind of is, you can think of as a bit of a companion to this, where we show how to take a model kit once you've got that and turn it into a running container that you can either run locally or, even better, deploy forward into production for use by your users in a scalable, operationally responsible way. All right, so let's jump in. In this particular case, I am working in a group. My role specifically is to build a model that can be used to predict who would have survived. The separate data group has already grabbed a ton of data about the Titanic, about the ship, about passengers, and all the other things, and pulled that into our organization. They've collated it, so they've got that kind of raw collated data available. Now they built that as a model kit, and I can show you that right here. Yes. So this is the collated data. This is used for a number of different projects inside this group, and you can see even what this is, what this includes. We've got, let's close this up. We've got training data and testing data that's already been made ready for everybody, but that's not been processed. If you're wondering what I'm looking at here, this is the Jozu Hub. Jozu, and I'm actually the founder of Jozu, is actually a company making DevOps tools to simplify the lifecycle management of AI/ML projects in the enterprise. You can learn a bit more about that at jozu.com, but you'll see us using the Jozu Hub because it is a really great way to save model kits in a format that you can easily view. But you can save model kits in any container registry, Docker Hub, Artifactory, ECR, doesn't matter. They'll work everywhere. All right, so let's jump into the notebook now. In this particular case, I'm not going to walk through the details of the notebook. I'm just going to skim through it and show you where you would integrate the model kit parts. So skip over this stuff. We're first going to start by grabbing that collated data set. So I want to pull that onto my machine so I can use it with this notebook. So I've got some helper functions in Python that make it easier for me to interact with those model kits and with the hub. So in this case, I'm going to be unpacking all that collated data onto my machine. We'll see we log in, we run a kit unpack to grab that particular collated data v1, and then that's unpacked it to my local machine. Now I want to be able to view the model's kit file because I want to see what that looks like. You can think of a kit file as being like the recipe for a model kit. It kind of has the same function as a Docker file does to a Docker container. So if I run this, I now can see the kit file contents. So we can see I've got training data set, testing data set, looks exactly like what I showed you a second ago in the hub. All right, now we're going to load that collated data set from disk into my notebook, and we're going to take a quick look at it. Lots of different columns we can see, lots of different rows. I'm not going to take you through much of this. We're going to take a look quickly at what data is missing from that collated data set, because we're going to need to do a little bit of processing to make it more appealing for my model. Specifically, I'm going to make it so that the numerical values are all between 0 and 1. That just tends to work a little bit better. And I'm going to smush together the number of siblings and the number of parents into a single number of relatives column because I don't need any more detail than that. Now that I've done that, I'm going to run a pipeline to do the numerical attributes and now the categorical attributes. Finally, we're going to run a join to process both of those. And we're going to generate our labels. And finally, we're going to export all of that. Now that we've got that, let's update that kit file. And so what we're going to do now is we're going to end up creating a second model kit. That new model kit is going to be much more specific to my part of the project. It's going to include the collated data because I want to be able to show where the original data was and the exact state it was in when I ran my pre-processing and my feature analysis. It's also going to include that processed data because that's what I'll need to actually do the training. And so I'm going to save this as a model kit, even though I'm not done. I haven't done my model yet, because that's a really great starting point for somebody who might want to investigate an SVC approach instead of I'm going to use random forest. So I'm going to do that. This is going to add in the testing data, the training data, and the labeling. And then just to make things easier, I'm going to also include all my code files. So that's the notebook, the requirements TXT for Python, the kit file template in case somebody wants to create a different type of kit file for this, kit file helpers, model kit helpers for Python just to make my life a little easier, and the git ignore. So I'm going to run all that. Okay. And finally, I'm going to do my pack and my push. So I'm going to take now all of this new information that I've created, the process data, the notebook, all the various code pieces we need, and I'm going to pack those all up into a new model kit that is going to be called Process Data V5. You can see it's running now. One thing you'll notice is that it's not actually repacking layers that have already been packed. So it looks at that collated data that I pulled in and says, hey, I don't need to repack the collated data. I can just pull it in because it was already there. So save a bunch of time, and I push that. Now to see where that goes, I'm just going to jump briefly back over to the hub, and I'm going to show you, there's my process data V5. You can see it does not have a model, but it does have now 5 data sets and a bunch of code bases. Those 5 data sets, as you'd expect, the raw train and the raw test, the process train, process test are all there as well. Now I'm going to jump back to, to my notebook, and I'm going to do my model training. As I said, I'm going to use a random forest, so let's do that. I'm going to run a prediction, and I'm going to run my validation. Now, this performs an 81.8% accuracy. I'm not going to win any medals for that, but it's good enough for now. So I want to export this trained model. So first, I need to serialize it. I'm going to serialize it as a joblib format. Could have chosen another one. I like joblib. So pop that out, and then I'm going to update my kit file. You can see the update is fairly simple in this case because I'm just adding a single model. Titanic survivability predictor. You'll notice that I'm describing the fact that it's a random forest. That's important to my colleagues. And the fact that I'm using the joblib framework for it. Some licensing information, other things there. And now you see the full contents of the kit file for this particular project. Now that includes everything. All the data sets, the raw training and testing, the process training and testing, the labels. It's got my README and my license, my Jupyter Notebook, my requirements, all the various helpers, and the serialized model. Everything I could possibly need. So then the last step, I'm going to push this to trained model v2, push that away, login successful. I'm going to pack that. Again, it's skipping a bunch of layers that had already been packed and that have not been changed to make things a little bit easier. And I can look at the entire resulting kit file, or I can just jump over back here and see there's my trained model. It now includes the model as well as the datasets, code bases, docs, and config. Again, everything I could possibly need. Now, like I said, from here, it would be trivial for another member of my team to grab one of these model kits, pull it just like I did, unpack it just like I did, and then use it in their own Jupyter Notebook, or maybe they want to use MLflow, maybe they want to use weights and biases, maybe they want to use something totally different. Doesn't matter because the model kit format is standardized, so it'll work with any and all of those tools. Alternatively, maybe somebody looks at this and says, hey, that model is fantastic. Let's just deploy that to production. As I mentioned, there's a different video that shows you how you can take a model kit, convert it to a container, and then you could actually have that happen in a pipeline and just deploy it directly. You could deploy it locally and test it first. You could do integrations, embeddings, whatever else you need. The model kit format is powerful because of the fact that it's built on an OCI standard, which pretty much every organization already uses today. It is highly secure. It is completely immutable. You can even sign them. And if you use something like the Josu Hub, you can also see kind of what differences are between it. The last quick cool thing I'll mention is that although these, as you can see, these model kits can get quite large at 3 megs, I actually have the ability to unpack only pieces of them. So if all I needed was a serialized model, maybe because I'm deploying it, I could do an unpack -- filter with Kit, and now I've got just the model. Or I could get just the data set. It allows me to fit it in with the existing tools that I have, the existing workflows I have. It's great for DevOps, SREs, data scientists, ML engineers, everybody who works with data and wants to see a little bit more structure, a little more security, a little more reliability. Love to get your feedback. Reach out to me in the comments or over LinkedIn, or join our KitOps Discord channel. Thanks very much.